Have you looked outside and wondered, why is it so cold, even in Texas? It's a question that's been on everyone's mind lately, as cities famous for their warm weather are suddenly blanketed in snow and ice. For many people living in the South, this kind of deep freeze feels almost surreal. After all, these are places where winter usually means a light jacket, not heavy coats and snow boots. So, what's going on? Why are we seeing temperatures plunge so far below normal, and why does it seem like the cold just won't let up? It feels like someone left the planet's freezer door open. The air is crisp, the wind bites at your cheeks, and even the most seasoned Southerners are shivering. Schools are closed, roads are icy, and people are swapping stories about the last time it was this cold, if they can even remember it happening before. The South is used to heat waves, not cold snaps, so this weather has caught a lot of people off guard. The culprit behind this dramatic chill is a massive blast of Arctic air, known as the polar vortex, that is swept down from the North Pole. This isn't just a regular cold front, it's a powerful system that can transform sunny southern states into a winter wonderland almost overnight. When the polar vortex escapes its usual boundaries, it brings with it some of the coldest air on the planet, plunging temperatures and creating scenes that look more like Canada than Texas or Georgia. Today, January 21st, 2026, this powerful system is chilling much of the US, from the Midwest to the Gulf Coast. Cities that rarely see snow are waking up to white rooftops and icy streets. The impact is widespread. Flights are delayed, power grids are strained, and communities are working together to stay safe and warm. It's a reminder of just how powerful and unpredictable nature can be, especially when it comes to the weather. But what exactly is the polar vortex, and how does it send shivers so far south? The polar vortex is actually a giant ring of cold, fast-moving air that circles the North Pole high up in the atmosphere. Most of the time, it stays put, locked in place by strong winds. But sometimes, those winds weaken or wobble, and the cold air escapes, spilling down into North America and bringing frigid temperatures with it. We'll explore the science behind this deep freeze, from the forces that usually keep the cold locked up north to what happens when they fail. Meteorologists use a variety of tools, like weather balloons, satellites, and computer models, to track the movement of the polar vortex and predict when it might break loose. Understanding these patterns helps us prepare for extreme weather and stay safe when the temperature drops unexpectedly. We'll also see how the jet stream acts as a weather fence, and how a wobble in that fence can mean snow in Houston. The jet stream is a fast-moving river of air that usually keeps cold air trapped up north, but when it dips or bends, it can open the door for Arctic air to surge southward, bringing snow and ice to places that rarely see it. This is why you might find yourself scraping ice off your windshield in a city better known for its summer heat. So grab a warm drink, and let's dive into the science of this spectacular winter freeze. Whether you're a weather enthusiast or just trying to stay warm, understanding what's happening in the atmosphere can help make sense of these wild temperature swings. Bundle up, stay safe, and join us as we unravel the mysteries of why it's so cold down south this winter. At the top of the world sits the polar vortex, a giant whirlpool of frigid air spinning over the Arctic. It's a permanent feature, strongest in winter when the North Pole gets no sunlight, locking in the cold. Normally, the vortex acts like a wall, keeping Arctic air contained. But sometimes, sudden warming events high in the stratosphere disrupt it, making the vortex wobble and stretch. When this happens, the cold air escapes, spilling southward. It's not that the vortex itself moves to Texas, but a piece of its icy air does. This is how a stable, spinning top of cold can suddenly send a chill across continents. The current event is a classic example. A weakened vortex has let Arctic air pour into the US. That's why you're bundling up in places that rarely see snow. When the polar vortex weakens, a chain reaction begins high above the Earth's surface. The polar vortex is a vast, spinning mass of cold air that usually stays locked around the Arctic, held in place by strong winds. But sometimes, those winds falter. When that happens, the vortex becomes unstable, and its icy grip loosens. Lobes of cold air, like giant icy tentacles, break away from the main vortex and plunge southward. On weather maps, you can see these cold air masses spilling out of the Arctic, surging down into North America and beyond. It's as if the Arctic is exhaling, sending frigid breaths across the continent. These icy chunks descend into the troposphere, where our weather happens, and invade neighborhoods far from the Arctic. Suddenly, places that rarely see snow or ice are transformed overnight. Streets that are usually busy with everyday life become quiet, blanketed in white, as residents wake up to a world that feels more like the North Pole than their own backyard. Think of it like a freezer door left open. Cold air spills out, chilling everything in its path. The frigid air doesn't just sit still, it seeps into every corner, wrapping around buildings, trees, and people. The temperature drops rapidly, and the familiar landscape is suddenly transformed by frost and ice. As this Arctic air moves south, it follows invisible highways in the atmosphere, guided by high and low pressure systems. These pressure systems act like traffic signals, steering the cold air along certain routes and pushing warmer air aside. The result is a dramatic clash of temperatures with the cold, front bulldozing its way through milder regions, leaving a trail of winter weather in its wake. Sometimes as the Arctic air travels, it picks up moisture from large bodies of water like the Great Lakes or even the Gulf of Mexico. This added moisture fuels powerful snow and ice storms, dumping heavy precipitation in places that are unprepared for such extremes. Cities in the south, more accustomed to sunshine than snow, can find themselves paralyzed by blizzards and ice storms that seem to come out of nowhere. The impact is felt everywhere, from frosted over windows and icicles hanging from rooftops, to families bundling up in layers they rarely need. Schools close, roads become hazardous, and communities must quickly adapt to the sudden freeze. The South, known for its warmth, is temporarily transformed into a landscape of shimmering ice and snow. In January 2026, NOAA tracked the vortex's instability and warned of the coming freeze. Meteorologists watched their screens as the cold air surged south, issuing alerts and preparing communities for the unusual weather. Their forecasts became vital lifelines, helping people brace for the cold and stay safe during the storm. This journey of cold air is a powerful reminder of how interconnected our planet's weather systems truly are. A disturbance in the Arctic can ripple outwards, affecting millions of people thousands of miles away. The spinning globe of weather patterns shows just how quickly conditions can change, linking distant regions in a shared experience. The icy Arctic and sunny Texas are linked in a dramatic, chilly embrace. It's a striking contrast. One moment, the South basks in warmth, and the next, it's swept up in a wintry blast from the far north. This connection highlights the delicate balance of our climate, and the surprising ways it can shift. That's how a polar vortex event can turn the South into a winter wonderland. Palm trees dusted with snow, children building snowmen where they usually play in the sun, and families marveling at a rare and beautiful transformation. The journey south of the polar vortex is a story of nature's power, unpredictability, and the remarkable ways our world is connected. Meet the jet stream, a fast, high-altitude river of air that circles the globe, thousands of miles above our heads. Invisible to the naked eye, this powerful current is constantly on the move, shaping the weather we experience every day. It's not just a single stream, but a complex system of winds that can reach speeds of over 200 miles per hour, acting as a boundary between different air masses. Think of the jet stream as a weather fence, separating frigid polar air from milder, warmer air to the south. This invisible barrier is what keeps the seasons in check and helps determine whether you'll need a winter coat or a t-shirt. When the jet stream is strong and flows in a relatively straight path, it acts like a tightly sealed gate. Cold air stays locked up in the Arctic, unable to spill southward, while warmer air remains to the south. This stability means predictable weather patterns and fewer surprises. In this state, the Arctic remains icy and isolated, and the rest of the continent enjoys more moderate conditions. The jet stream's strength is like a shield holding back the harshest cold. But sometimes, the polar vortex, a swirling mass of cold air that sits over the North Pole, weakens. This can happen when the stratosphere above the Arctic suddenly warms, disrupting the vortex's stability. When this happens, the jet stream loses its straight, strong shape and begins to meander, forming dramatic waves that dip far to the south and rise far to the north. These southward dips allow icy Arctic air to escape its usual confines and surge into regions that are normally much warmer. Suddenly, cities that expected mild winters are plunged into deep freezes. These dips, called troughs, act like open gates in the weather fence, letting the coldest air pour southward. The deeper the trough, the farther the cold can travel. That's why, when a deep trough forms over North America, Arctic air can sweep across the U.S., bringing sudden snowstorms, icy winds, and record-breaking low temperatures to places unaccustomed to such extremes. Right now, that's exactly what's happening. A deep trough in the jet stream is allowing a lobe of polar air to surge south, triggering blizzards and bitter cold across the Midwest and beyond. This lobe of cold air is chilling the central and eastern U.S., transforming landscapes overnight and challenging communities to adapt to the sudden freeze. From scraping ice off windshields in Chicago to trudging through snow in New York City, millions are feeling the effects of this dramatic shift in the jet stream's path. But the jet stream doesn't just create cold. Where it bends northward, forming ridges, it can bring unseasonably warm air to places that are usually frozen. That's why, while the Midwest shivers, Alaska might bask in temperatures that feel more like spring than winter, with people trading parkas for light jackets. These dramatic waves in the jet stream explain why we can see blizzards in one part of the country and sunshine in another, all at the same time. The contrast can be striking, sometimes a matter of just a few hundred miles. On a global scale, the jet stream's undulations create zones of extreme cold and warmth, shaping weather patterns not just in the US but around the world. It's a reminder of how interconnected our planet's climate truly is. The jet stream is the delivery system for the polar vortex's chill, carrying cold air southward and dictating where winter's harshest conditions will strike next. Meteorologists watch its every move to predict storms and temperature swings. When the jet stream wobbles, the polar vortex's icy grip can reach much farther than usual, sending blasts of Arctic air deep into the heart of continents and making winter weather unpredictable and wild. So, The next time you find yourself in the middle of a wild winter storm or enjoying an unexpected warm spell, remember, it's the jet stream, our planet's ever-shifting weather fence, that's calling the shots. Snow and ice in Texas. It happens when Arctic air meets moisture from the Gulf of Mexico. The cold, dry air travels south, then collides with warm, moist air from the Gulf. This clash forces the moist air to rise, cool, and condense, creating clouds and precipitation. If the air is below freezing all the way down, you get snow in Dallas. Sometimes layers of warm and cold air mix, leading to sleet or freezing rain. Freezing rain is especially dangerous, coating roads and power lines in ice. That's why a polar vortex event can bring classic winter weather and hazards to places that rarely see it. The recipe: Arctic air plus Gulf moisture equals southern snowstorms. How did we know this big freeze was coming? Powerful computers and weather models. Organizations like NOAA use global forecasting systems, simulating the atmosphere with data from satellites and ground stations. These models run millions of calculations, predicting how pressure, temperature, and the jet stream will evolve. For this event, models showed a high chance of a stratospheric warming that would destabilize the vortex. Meteorologists use ensemble forecasting, running models with slight variations, to see if most agree on a cold outbreak. This gives cities and emergency services time to prepare, treating roads, warning the public, and protecting infrastructure. For you, it means time to stock up and get ready. Forecasting turns a potential disaster into a manageable, if chilly, event. Ever notice the feels-like temperature is colder than the actual air temperature? That's wind chill. Your body creates a thin layer of warm air next to your skin, but wind strips it away, making you lose heat faster. The faster the wind, the colder you feel, even if the thermometer doesn't change. The National Weather Service calculates wind chill using air temperature and wind speed, giving a better sense of frostbite risk. Wind chill only affects living things, not objects like cars or pipes. So, when the wind chill is low, bundle up and cover exposed skin. It's a real danger during a polar vortex. With these intense cold snaps, you might wonder, will this keep happening? Paradoxically, as the Arctic warms faster than the rest of the planet, the polar vortex can become less stable. A weaker, wavier jet stream lets Arctic air spill south more often, causing extreme cold events, even as global temperatures rise. So, a warmer Arctic can actually mean more wild winter outbreaks for us. This doesn't contradict global warming. It's a sign of how complex our climate system is. We'll see more heat waves overall, but also need to prepare for sudden dangerous plunges of Arctic cold. Resilient infrastructure and smart planning are key for the future. We've explored how the polar vortex can send Arctic air south, guided by a wavy jet stream. When a polar vortex event is forecast, take it seriously. Stay informed with local weather updates. Prepare your home, check your heating, insulate pipes, and have an emergency kit ready. Dress in layers, cover exposed skin, and limit time outdoors to avoid frostbite and hypothermia. Check on neighbors, especially the vulnerable. Community support is one of our best defenses against extreme weather. The polar vortex is a reminder of nature's power, but with knowledge and preparation we can stay safe and warm. Stay warm out there.